Okay, so this is 4.1D. Section 4.1 is System of Equations, solving system of equations by the graphing method. And this is graphing the same line. And what does it look like? And what kind of solution do we get? So that's 4.1D like David. C was graphing no solution. Uh, B was graphing, just simply graphing to get a point. And 4.1A was introduction and kind of a, confirming that we had a test point. So let's go up here to our next system of equations equals, I think, this one here. Graph these lines and determine the intersection, which is the solution. So we're going to say, number one, sorry about that. Whoops. Let's go down here. Right there. All right. Step number one, graph the lines. Step number two, determine the intersection, which is the solution. What's our solution? X, Y. We've got to have an X and a Y, and if it would be the same thing if I said solve this system of equations. You've got to come up with an X and a Y. Don't make the mistake of, because I've seen some people do this. Come up with an X and then say, "Oh, I'm done. Move on." Make sure you don't do that. All right. We've got to graph the lines, determine the intersection. All right. Well, if we're going to graph the lines, we're going to put them into y equals mx plus b format, which is the slope intercept format. M is the slope. As long as an equation is solved for 1y equals everything else, then the number in front of the x variable, the coefficient of the x, gives us our slope, and the b tells us our y-intercept. All right, so let's call this one our green line. We'll say x minus 3y equals 6. All right, well, we're going to modify that to put it into y slope-intercept form. So we start with x minus 3y equals 6. All right, positive 6. We're going to move everything over and get the y just by itself. So we subtract x, and we've got negative 3y equals a positive, minus negative x plus 6. And we've also got to divide by negative 3 because we need our coefficient of y to be 1. So a negative 3 divided by a negative 3 gives us a 1y equals negative 1 divided by 3. So if we've got two terms here, we can divide each term, the x term and the 6 term, by that negative 3 if we've got one term underneath. So negative 1, we've got an unwritten 1 there. And so negative 1x divided by negative 3 is negative divided by negative is a positive. So we've got 1/3 x, or 1 over 3 x. And then the next term is positive 6 divided by negative 3 is negative 2. So there's our green line modified to be into slope-intercept form. All right, so now we can say, what's our red line? Our red line is going to be right there. Y equals 1/3 x minus 2. All right, well, I tell you what, we've already got it into slope-intercept form here. So let's see. Does anybody see anything that makes this jump out at us and say, wait a minute, do we have to graph this? We really don't have to, I suppose, because we can take a look at what's here in the red. Y equals 1/3 times x minus 2, and the green is y equals 1/3 x minus 2. If we graph one of them, they look like the same line. So really, let's graph one of them just to make sure. And I will say, let's graph the red line or even the green line. Let's see, slope of the red line equals 1/3 equals rise over run. And our b is negative 2. Our y-intercept happens when x equals 0 and b is negative 2 for this situation. So we can graph this point. 0 in the x direction, negative 2 in the y direction is right there. And then we use our slope of up 1 over 3. Up 1 over 3. And we get another point there. And sure enough, there's our red line. Hopefully it gets, there we go. Sorry, my hand came off the pad here. All right, so there's our red line. But you know what? If we graph our green line as well, we can say, well, slope is 1/3. Y-intercept is negative 2, so our green line is right there as well, and our slope does the same thing, up 1 over 2, over 3, up 1 over 3, rise of 1, run of 3, and we've got, again, the same line right there. So when we graph it, there's what the graph looks like. So what's our solution? Infinite number of solutions, infinite solution. And probably the best way to say it would be, what's our solution set? Y equals 1/3 x minus 2, because it's not just any one point. It's that point and that point and that point and that point and that point. All these points along the line is our solution set, and that's best described by this line here, y equals 1/3 x minus 2. That's our line. That's our, in fact, that's both of our lines. That is our solution set, and we're done. There's our solution set, y equals 1/3 x minus 2.